Hello.
Yeah, this is really boring. Okay, so using your calculator. So Kian made a very, very interesting point there, Kian. Would you like to repeat that point?
Well, I said
Something about you always cheat in exams.
No, I was just asking because calculators may count as cheating in some places.
Okay, so the thing is, yes, you need skills, numerical skills, algebraic skills, where a calculator cannot help you. So you need to know the rules for mathematics. Now, a calculator is a tool in the same way that a carpenter uses a saw to cut the wood. Now, you would never say to him, but that's cheating. You should be using your fingernails. Okay? But if he doesn't use it correctly, okay, or for instance, let's say you've got a normal hand saw, or you've got a nice big electric saw that does it really quick, very easily. It's not cheating, but if he uses it incorrectly, the job won't be done as well. So you've got a really useful tool, but you have to learn how to use it. Now, a calculator is like any other computer. Right? It's stupid. It is stupid. Okay? Calculator has no imagination. It has no ability to reflect on what you've done. It cannot speak to you and say, sorry, Louis, you've done that wrong. I don't think you wanted to do it that way. And you can go, oh yeah, thanks calculator for that. It does exactly what you tell it to do, but follows the rules that are programmed in. Okay? And the rules that the calculator follow are BODMAS. Okay. It will do brackets first. Okay. Then it will do powers, and then it will do multiplication, division, left to right if there's more than one. You know, it will do addition and subtraction last. It follows those rules. So if you put something in and you are not paying attention to BODMAS, the calculator will give you the correct answer, but you put in the wrong question. Right? And it's amazing how many people will say, this plot's calculator broken. Why is calculator? It always told me the wrong answer. And I bet it's the same people that say that throw their PlayStation controller across the room at the TV and say it's cheating. Yeah.
Why are you looking at me?
I don't have a PS4 yet.
Anyway, right, that's the deal, isn't it? How many people have said the computer's cheating? Yeah, me actually. When I was younger, I've done it and I've done it. Like, oh, the computer's cheating! You know? And it's not, it's following a set of instructions, a set of rules. It's just up to you to adapt to beat those rules. Right? Now, we've just got to learn. So, as I said, with our little calculators, we don't have brackets. Now, in the book, it tells us about the memory, but what I'm going to... Do you know how to use the memory on the calculator, what it's for?
No.
Okay. Basically, then, we need to look at, if it's necessary, we might need to know how to put a number in memory and then use it. Now, if you look at the top of your calculator, there are 3 buttons in blue, which are MRC, M-, M+. Okay? So, what do you think they are? Do you know what MRC stands for again?
I don't know, maybe it's a memory record.
It's not actually, no.
Memory calculator?
No. Is it? No. No. Daniel?
Memory read.
Oh. No.
Memory read cell.
No. We're all guessing now.
I'm pretty sure about it.
Memory reading computer.
No.
Memory record capture?
No, it is actually, because none of you are going to do it.
Well, I got that far. I mean,
Recall. Oh.
Memory recall. Because it makes sense that there must be a button to put something in a memory. There should be a button to
Take out
show
memory.
what's in the memory, and then there should be a button that deletes the memory. So MRC is for memory recall, that brings it out. Okay. M plus is
To bring it in.
put it into memory. Okay. And then M minus will be
Take it, delete.
delete it. Okay. So let's just check. Put a number on your calculator.
21.
Okay. Well, actually, no. First, press MRC and see whether anything comes up.
No.
No.
No. Okay. Press a number
21.
and then press M plus.
Oh, 1 digit.
Anything. Put something in there. The one that you can remember. Press M plus. Press then on C at the bottom to clear your calculator, and then press MRC.
Oh.
Right?
Oh, that's.
Oh.
Okay.
Yes, there's an M button. Yeah.
What?
Yeah. Yeah.
Yeah. So if you have something in memory, what appears at the top of the screen?
M.
An M tells you there's something in the memory. If you press M minus,
It disappears.
it disappears.
Yeah.
Okay. Now if you press MRC, nothing comes up. Okay. So that's the basics of it. So we can put one thing in memory on these little calculators, just the one thing, right? So when we do calculations like these, for instance, right, that I've got on the board that I've picked out from the book, we can try using our calculator. Now, the thing is, often, just as useful is just writing down your answer on a bit of paper, okay, showing you're working, right? Now, sometimes, however, when we've got decimals especially, if we can put every single number into the calculator before we press equals, what that stops us having to do is, well, any ideas what it stops us having to do? If the calculator, we can put it all into our calculator and press equals, what does it stop us needing to do? Writing down the answer is not one of them.
Carrying out multiple operations.
But that's not a problem unless we have to do what?
Using the memory. You don't need to use the memory.
No, that's what we want to do. We want to have the calculator do it all in one go. Think about what this whole unit's about and has been about. What's the unit about?
Estimating and rounding.
Rounding and estimate, yeah, estimating and rounding. So,
We can't estimate.
not can't, you don't have to,
Oh.
because what happens is, if you have to write down numbers that end up with division especially, might end up as a decimal that's too long to write down. Okay, and you then have to round it. Okay, and as soon as you round it, what happens to your answer? Yes, that's accurate. So ideally, we don't want to round it, and the best way to do that is to have the calculator do it all in one go, and then it will give us the most exact answer we can. So that's the idea. All right. Now we'll look at these questions, and we've just got to work with BODMAS, for instance. So let's have a look at this. What was it? 8 plus 6 over 9 plus 7. Now, if we were going to do it in our heads, it'd be really easy. What would you do first? John? You would do the 9 plus 7, wouldn't you? Right? Because division first. So your first step would be 8 plus 6 divided by
16.
16. Okay? Then what would you do? Is it 6 divided by 16? Right, now here's the thing. If you type now into the calculator that 8 plus 6 divided by 16, what answer do you get?
0.875.
What is it?
0.875.
0.875. Okay. Are you correct? Why not?
Maybe, yeah.
You just said no because I've asked the question and you think it's... Come in? You think we would have to do 8 plus 6 and then divide... Okay, so what did the calculator do with this? Here?
It divided 6 by 16 as it's using the BODMAS rule, then it adds 8. Oh no, it doesn't.
No,
Obviously hasn't actually, has it? Look.
What it did was it added the 8 and the 6 and then divided by that.
Yeah, so in this case, it didn't do the BODMAS because we've got cheapy calculators. Okay? So it did 8 plus 6, which is
14.
14, and then did divide by 16, which is...
Eight.
So what we actually need it to do is...
First,
Yeah, we need to do... So for you guys, you could, if you were going to do this, what you would do is do 8 plus, work out 6 divided by 16. What is it? 6 divided by 16.
0.
Exactly? Is it an exact number?
Yeah, it is.
Okay. Well, here's the thing. So show you what we do with the calculator then. If you do 6 divided by 16, okay? See, on a fancy calculator, I would put that in brackets. But on these calculators, what are you going to do? If we're going to bother. Sushi?
6 divided by 16 plus 8.
Well, you could try that. What does that give you? 6 divided by 16 plus 8. Does that give you the right answer now? That makes more sense, doesn't it? What about, let's just practice, because I know this is the idea. Do 6 divided by 16 and then stick that into the memory. Okay, do 6. So, one thing we could do, you're right, is 16 over 16 and then add 8. So on a calculator, 6 divided by 16 add 8 seems to be a better way. That's us knowing that. But what if you were to do 6 divided by 16, do memory plus, right? And then do 8 plus memory recall and plus equals. Yeah, you get that answer.
That's cool.
So that's the idea with this calculator logic. Alright? Make sense about that? Alright, so we get the answer. We think the correct answer is 8.37. Now, here's my biggest thing I want to say about this. For all of these questions, you do know what to do. Okay? You know what to do. The calculator doesn't know the question. It can't read the question. So it's up to you entirely about you doing things in the right way. So, for instance, if we were to look at B, what would you do first? What would you put in the memory of the calculator? Yeah. Ooh, I can understand why you just put the top. But what do you have to work? What would you work out first if you were doing? So you would do the top and the bottom. Okay. Now, if I put this into a calculator, 19 plus 12.2 divide by 8 minus 3, are you going to get the right answer? No. Now, in a nice fancy calculator, I would put brackets around this and around this. You can't do that. You've got these cheapy ones. So, you've got to think, logic, what has to go? What's the best way of doing it? So I would do, 8 minus 3 equals, which would be 5. I would do memory plus,
and then you do
1.9
plus 12.2
yeah.
divided by
Okay. But we probably, because of our calculators, need to do equals, find the answer, and then do divide by memory recall. So if we try that, guys, with those calculators. So we'll try this. So first of all, make sure your memory's clear. Do 8 minus 3. I know it's sort of easy numbers anyway, so you start to realise actually it's easier not to bother. But we do 8 minus 3 equals 5. put it into the memory. Make sure your memory was clear first.
Got it.
Right? Okay. Got the answer?
Yeah.
2.82.
2.82.
2.82. Okay. Alright. Now,
That's the wrong one.
again, because we haven't got nice scientific calculators with brackets, these ones are more difficult. Alright, so my advice to you would be, well, actually, you come up with your own name. If you've got to sort this one out, or this one out, using this calculator, probably what's the best method? Sushi?
Maybe we should add the bigger numbers. We should we should put in the memory the bigger sums and
Well, the memory is only kind of useful to some extent. That's why I say I never use it anymore. I just don't bother. So if I was to do this sum, probably the best option is for you guys to show your working out. Okay? That's what I would say. So for this one, for instance, I would be working out that top line. Now here's the thing, this is the big thing for you guys, is knowing that you can't put all of that and then put divide and then all of that, because this long line means you have to do all of that first and divide by all of that. So you need all of that answer before you can do the division. Okay, so that's the important thing. Right? Yeah. Once we get bigger, fancier calculators, so when you're in year 10 and you've got one of these things,
Yeah.
right? If you've already got one, then you can put brackets. I can put all of that exactly as it is on the calculator, and it's really easy. So that's the advantage.
You can even like draw hearts
On
on that.
But then,
Mr. Larson taught us how to draw a heart. With
yeah.
about
But right. So at some point we'll get there. If we've got other scientific calculators, they don't need to be like that. So, for instance, let me show you the ones we've got. Coffee.
have to use the cheapy ones right now.
It's because you're cheap.
If you are going to buy a calculator,
Well, I have the same one.
yeah,
I have the same one.
these are the ones we can recommend. But
Can I see it?
when you get to year 10, you'll be expected to have the big graphical calculator. But that's got brackets and memory and all sorts of things. So even on one of those, we can cope with this kind of equation.
But that's not the big one.
No, that's not a big graphical. That's much cheaper. The graphical one is about 120 pounds. Okay. Anyway, so the point of this is you've just got to know that your calculator relies on you, not the other way round. So if you ever say to me, the calculator got it wrong, I need you to stop and think about how silly you sound. Okay, and think, actually, I need to do this properly. So can I get you now, you've got the book, I think page 80, 70, whatever, 76. Can I get you to do those questions? So question 3, it's on the board, and then you can do, so what's it page? Actually, it's page 79.
Yeah.
To go to question 3, what you to come up with your answers, thinking best way possible of using your calculator, but in combination with writing down a clear solution showing your working.
But do we do A, B, and C? Like, because we've already done A, B, and C.
Well, we haven't done C. We've got C and D to do.
Okay, so we have to show our working?
I've even got that on video, me just saying that, like literally 5 seconds ago. Yes, you have to show your working. I said I want a combination of use your calculator but show your working out, show your working methods. Okay?